Hello friends, this chapter is about the introduction of CCTV system. We all are seeing CCTV cameras almost every day, whether it's in the shops, offices, city traffic lights, government buildings, etc. Now, we all are surrounded by the CCTV cameras. In few countries like China, to every person there is a CCTV camera and it's increasing day by day. So, what is CCTV camera and what is their use? Why we are seeing this camera all over? Let's see. CCTV system stands for closed circuit television system, which means that the TV signals are transmitted privately distributed for monitoring purposes, especially for surveillance and security purposes. Suppose in a high-rise buildings, a security person can monitor all the floors or the area of interest by just sitting in front of a CCTV system, which in turn increases the response of the security person in case of any emergency, and the recorded videos can be later used as an evidence for any jurisdictional purposes. In our next video, we will learn about applications of CCTV systems. Hello friends. This chapter is about the application or uses of CCTV systems. CCTV systems are mainly used for security and monitoring purposes. CCTV systems has various applications in different areas. It is an excellent video surveillance solution that not only beefs up security and facilities monitoring but is also very useful in general observation. Now let's see the areas where CCTV systems are being used. Crime solving. CCTV system is a very powerful tool in the crime investigations and many times criminal cases are solved through CCTV recorded video footages. In a survey, it's found that in London, 6 crimes are solved each day through CCTV video footage. Vehicle traffic flow monitoring. In many countries, CCTV systems are used as a part of an advanced traffic management system which is used to control and monitor vehicle traffic on highways and roads. Personally, I am seeing CCTV cameras almost every day which are installed on highways. These cameras are very special cameras which takes a photo or video of the vehicle number plate whenever a vehicle crosses the speed limit. This recorded footage is used as an evidence by traffic authorities to find an individual driver if he has exceeded the speed limit. Some of the cameras are so advanced that they can generate alarms inside the control room when a vehicle stops on highway, like what we have seen in this image, and if a vehicle is moving in the wrong direction. Use in colleges, schools, offices, shops and public places. Places of public gatherings, schools and offices many times requires to be monitored continuously in order to check and take effective measurement in case to prevent bullying, vandalism or any sort of crime. At the same time to record the video footage which may be used as an evidence during post-investigation. However, the CCTV designer must always be cautious and should not place the camera in some locations like bathrooms, private properties, locker areas, etc. Now let's move on to our next chapter, that is the types of CCTV systems. Hello friends, welcome to this chapter about types of CCTV systems. CCTV systems are majorly of two types. First, analog CCTV system and IP CCTV system. Let Analog CCTV system. Analog CCTV system are basically old and analog system. In this analog CCTV system, as shown in the image, captured video signals from analog CCTV cameras are transmitted over coaxial cable to the DVR for live view and recording purposes. To power up the analog CCTV cameras, power supply from the recommended manufacturer is used to power up the analog cameras. Monitors are connected directly to the DVR for live view or to check the recorded video footages. Digital video recorder converts these analog signals into digital signals and then compresses the data so that it can be stored on hard disk drive. For internet viewing of this live view or recorded video footage, DVR is connected to the internet via a modem. Video quality of this analog CCTV system are generally in TV lines or VGA, which is lower than the video quality offered by IP CCTV system. IP CCTV system. In IP CCTV system, CCTV cameras as shown in the image are of high video quality like 1 megapixel, 2 megapixel, 5 megapixel or even higher. IP CCTV cameras captures the video signals in high quality and then compresses the data on board, which is different as compared to the analog CCTV system, which in turn helps in reducing the bandwidth of the transmitted data. This compressed data are then transmitted over Cat5 cable as shown in the image to the network video recorder via switch. To power up IP CCTV cameras, a PoE switch is generally used, which is shown in the image. PoE switch is used to power the CCTV cameras as well as to carry the data over a single Cat5 or Cat6 cable, which is different as compared to the analog CCTV system. Network video recorder further processes and compresses the received data and then stores in a hard disk drive or network attached storage. In order to live view or to see the recorded video footage, a monitor may be connected directly to the NVR or generally a workstation is connected to the NVR where VMS is installed. VMS is our video management software. Now let's move on to our next chapter, that is pros and cons between analog and IP CCTV systems. Hello friends, welcome to this chapter. In this chapter we will learn about the advantages and disadvantages of analog CCTV system and IP CCTV system. Analog CCTV system cost is comparatively lower as compared to IP CCTV system. This is because analog CCTV components are cheaper as compared to the IP CCTV system, while IP CCTV systems are costlier as compared to the analog CCTV system, hence its prices are also higher. Cabling. As analog CCTV camera requires two separate cables, one for video transmission and another for power supply. Hence, it requires more cabling infrastructure, while IP CCTV camera requires only a single Cat5 or Cat6 cable where both data and power supply are transmitted over a single Cat5 Cat6 cable. Hence, it requires less cabling infrastructure than analog CCTV system. Bandwidth. Analog recorded video files are smaller as the quality of the video is lesser as compared to the IP CCTV system. Moreover, DVR sends the data over network only when requested by any client. Hence, the requirement for analog CCTV system for bandwidth is lower as compared to the IP CCTV system. While as the IP cameras are of higher video quality like 1 megapixel, 5 megapixel or even higher, and frame rates also is higher with bit rate, which in turn requires more bandwidth. IP CCTV system is more bandwidth hungry than analog CCTV system. Video quality. Analog CCTV cameras are of lower video quality in terms of TV lines or VGA quality. Hence the video quality of analog CCTV system are of lower quality as compared to the IP CCTV system. While IP CCTV cameras are of higher video quality like 1 megapixel, 2 megapixel, 5 megapixel or even higher. Hence the video quality of IP CCTV system are more as compared to the analog CCTV system. Security encryption. Analog CCTV cameras capture videos and then transmit over coaxial cable which can be easily hacked. Hence, there is no security during data transmission in analog CCTV system. While in IP CCTV system, IP CCTV cameras captures videos and then encrypt this data before sending it to the NVR. NVR also further encrypts this data, which in turn add an additional layer of security. Hence, there is a higher level of security encryption during data transmission in IP CCTV system. Now let's move on to our next chapter. See you there. Thanks. Hello friends, welcome to this chapter. In this chapter, we will learn about the video resolution standard in CCTV system. Pixels. What is pixels? Every image which we are seeing are made up of pixels, and the collective group of pixels defines the resolution of an image. Resolution is technically the number of pixels per unit of area. Resolution has been described by the number of pixels arranged horizontally and vertically on a monitor. For example, if a resolution is termed as 640 into 480, it means there are a total of 3,72,000 pixels. HD resolution versus megapixel resolution. HD means high definitions. HD refers to the cameras with a standardized resolution of 720p or 1080p. The numbers 720 and 1080 refers to the horizontal resolution. Therefore, 720p HD or HD ready camera resolution provides images that are 1280 into 720 pixel, which is about 9,21,600 pixels. SD video format uses an aspect ratio of 16:9 and frame rate is standardized at 60, 50, 30 or 25 frames per second. We will learn about frames per second in our upcoming chapter, which also plays a crucial role in resolution and data storage calculations. As you can see in the image here, 640 pixels are arranged horizontally and 480 pixels are arranged vertically, which gives a total resolution of 3,07,200 pixels. And this is the quality of this video is of VGA quality. One could consider a HD as a subset of megapixel. Any camera with a resolution of more than a million pixels is defined as a megapixel camera. Megapixel cameras are coming in a wide range starting for 1.3 megapixel, 2 megapixel, 3 megapixel or even higher. Here in this image you can see there are 1920 pixels are arranged horizontally and 1080 pixels are arranged vertically, which makes total resolution of more than a million, and this camera is considered as 2.1 megapixel resolutions. Higher megapixel resolutions cameras are required where more detailed information is required. For example, cash transacting counter, jewelry stores, vehicle license plate detection, etc. Now let's move on to our next chapter, that is frames per second. See you in our next lecture. Thanks. Hello friends, welcome to this chapter. In this chapter, we will learn about another feature of CCTV camera, frames per second or FPS. The videos which we are seeing are actually a collection of static image. It's an illusion for our eye which makes us feel that we are seeing a video, but instead it's just a collection of static images which moves at a very faster rate which a human eye can't recognize. The rate at which these consecutive full screen images are displayed each second is called frames per second or FPS. On an average, a human eye can process 12 separate images per second, which means a frame rate of 12 FPS can display motion but will appear choppy. Greater the FPS, smoother the video will appear, as shown in the right image. Here, you will see that in a second there are a total of 9 different frames captured, and in the below there are a total of 6 different frames captured per second. These all frames are different and are captured at a microsecond intervals. When we move these images at a very fast rate, we see these images as a video clip, which is an illusion of our eye. Actually, we are seeing only the images, not a video. Now, let's move on to our next chapter. See you in our next lecture. Thanks. Hello friends, welcome to this chapter. In this chapter, we will learn about another feature of CCTV camera, that is BLC or backlight compensation and WDR or wide dynamic range. Most of the people are confused between these two features and many times assumes that both of them are same, but in fact they are two separate features which a camera offers. See what is meant by BLC or backlight compensation. As shown in the image, you will notice that 3% images are more darker, which makes them unrecognizable. This is due to more light in the background. Here, BLC plays an important role to sort out this issue. Backlight compensation or BLC has been around for years now. It was a huge advance to compensate for overpowering and bright lights in the background. BLC feature splits the video into different regions and a different exposure is applied to each region. This results in correcting regions that have high level of light and maintains a normal range of light for the objects the camera is focusing on as shown in the image. In the image now you will see that the foreground image or the persons, these three-person images are now more clearer as compared to the earlier images which was not having this BLC feature. But now there's a now there's a drawback also while using this BLC feature as shown in the image. You will notice that now the background image is more brighter as compared to the earlier image. That is where WDR or wide dynamic features comes into place. Now let's see what is WDR or wide dynamic range. WDR is a far more advanced version of BLC, but the intent is the same. As shown in the image, BLC brings the objects. Here you will see this is the BLC feature. BLC brings the objects and the people into focus and you can distinguish who and what they are, but the background is all blurry. But in the WDR photo, which is on the right hand side, the foreground and the background are in focus. WDR refers to the ratio between the lightest and the darkest elements of an image. Cameras that have WDR have two image sensors. One is for high speed and another is for low speed video capture. They work together and provide a balanced image as what you are seeing in the image. Now the foreground as well as the background images are more clearer as compared to the BLC. Hope you are satisfied with this chapter. See you in our next lecture. Thanks for watching the video. Hello friends, welcome to this chapter. In this chapter, we will learn about video compression technology. By developing CCTV systems, developers had a challenge of storing large data and transmission of this huge data. Because CCTV camera captures video files in large format, especially if it's an IP camera, then it will capture video files in very high resolution of megapixels, which in turn requires a higher bandwidth to send these video files and large amount of storage to store these video files. To overcome these issues, developers comes up with an advanced solution which is called video compression. Let's see what is video compression. Video compression is the process of using a coder and a decoder short form codec to go through your video files to reduce or eliminate unnecessary files. This makes your video files smaller so you can store more video on your NVR, hard drive or camera's micro SD card. As shown here, a video encoder encodes and compresses the video frames, resulting in reduction of the size, which results storing of more data or video files on hard disks and also reducing the video transmission bandwidth requirement. Now, when an operator requests for this compressed video data, a video decoder decompresses the stored data into their original format into which the video was recorded. There are major two types of compression. First is S.264 and MJPEG. We will learn about only of S.264 as this is the most used video compression technology in the CCTV system. S.264 is a video compression technology or codec that was jointly developed by the International Telecommunication Union and International Organization for Standardization International Electrotechnical Commission Moving Picture Experts Group, which is called as MPEG. S.264 and AVC, both terms are same. Let's see an example. A single layer DVD can store a movie of around 2 hours length in MPEG-2 format. Using S.264, it should be possible to store 4 hours or more of video quality on the same disk, that is lowered bitrate of the same quality. As shown here, the S.264 compression format can deliver better quality at the same bitrate compared with MPEG-2 and MPEG-4 visual. As you will see, the left hand side image is not of good quality and it's a bit shady, while in the right hand side it's very good quality and it's a bit clear. Recent development in the video compression technology has introduced a very advanced video compression technology that is called S.265, which reduces the data storage and transmission load by 50% as compared to S.264. Now in the market there are few system manufacturers who have already started to use this advanced video compression technology. Hope you are satisfied with this chapter. See you in our next lecture. Hello friends, welcome to this chapter. In this chapter, we will learn about bitrate. We will learn about the bit. When an IP camera captures images, they are converted into digital packets that travels on the network. This type of data is a bit that computer and networking devices knows as zeros or ones. So, bit is equal to 0 or 1. 1000 bit is equal to 1 kilobit. Now let's see about bitrate. Bitrate is the amount of data that is moved from one point to another in a given period of time. What moves in this case are bits and the unit of time is seconds. In general, we are measuring bits travel per second, that is bits per second. See the factors that affect bitrate. There are many parameters which affects bitrate. Let's see each one of them. Video resolution. Video resolution is certainly one of the factors that greatly changes the image quality in your CCTV system. So, higher the resolution of your IP camera, DVR or NVR, the higher bitrate is required to transmit the image over your network. Frame rate or FPS. The greater the amount of frames in your video, greater is the data amount, which in turn increases the load on your network traffic. So, higher FPS is equal to higher bitrate. Compression. The more is the video compressed, the less bandwidth it takes for the transmission and storage space. But there is also a reduction in quality. Bitrate is directly impacted by video compression. So, higher compression is equal to lower bitrate. See the types of bitrate. There are basically three types of bitrate. First, CBR, which stands for constant bitrate, VBR, which stands for variable bitrate, and MBR, which stands for maximum bitrate. CBR, as name suggests, it aims for a constant or unvarying bandwidth level. Here the bandwidth doesn't change, but the video quality is allowed to change. VBR, it allows bitrate to change or vary but maintains a constant video quality level. While in MBR, it allows the bitrate to vary but up to only a maximum value which gets good video quality level. Hope you have enjoyed this chapter. See you in our next chapter. Hello friends, welcome to this chapter. In this chapter, we will learn about PoE or Power over Ethernet. What is PoE? PoE stands for Power over Ethernet and is a technology which allows to deliver electrical power as well as allows data transmission using the same Cat5 or Cat6 cable to the PoE enabled device. This eliminates the requirement of pulling another cable for power as well as the socket requirement near to the devices. How PoE works. Ethernet cable that meets the CAT standard consists of 4 twisted pairs of cable and PoE sends power over these pairs to PoE enabled devices. First PoE standard used 2 twisted pairs to transmit data while the remaining 2 pairs were used for power transmission. With the new PoE standards, power and data are both sent over all 4 twisted pairs. When the same pairs are used for both power and data, the power and data transmissions don't interfere with each other. That's because electricity and data are transported at opposite ends of the frequency spectrum. Electricity has a low frequency of 60 Hz or less, and data transmissions have frequencies that can range from 10 million to 100 million Hz. There are different PoE standards. According to IEEE, which stands for Institute of Electrical and Electronics Engineer Association, PoE standards has 4 types as shown in the below table. IEEE 802.3 AF PoE standard provides up to 15.4 watt of DC power on each port, whereas and this standard IEEE 802.3 AT or PoE Plus standard provides up to 30 watt of DC power on each port. These two standards uses only 2 pair each for data and power transmission to power devices. As the demand for more power was required for power craving devices, another PoE standards like IEEE 802.BT 802.3 BT, that is type 3, and like IEEE 802.3 BT, that is type 4, came into existence, which provides power from 60 watt to 100 watt on each port for high power devices. Hope you have enjoyed this chapter. See you in our next chapter. Hello friends. Welcome to this chapter. In this chapter, we will learn about different types of the lens used in CCTV camera. CCTV camera basically uses two types of lens. First, fixed type and second, varifocal type. In fixed type of CCTV lens, focal length of the camera is permanently set, meaning that the field of view of fixed lens camera cannot be changed. While in varifocal type of CCTV lens, focal length of the camera can be adjusted depending upon the varifocal lens size. As you can see in the left hand side image of CCTV lens, CCTV lens size is mentioned as 6 mm, which is fixed. While on the right hand side image of the varifocal lens, CCTV lens size is mentioned as 12 to 120 mm, which means the lens size may vary from 12 to 120 mm. Do you know what is focal length and the field of view? If not, let's see first what is focal length. As shown in the image, the focal length is the distance from the center of a lens to the focal point or sensor. Focal length is measured in mm, which is actually we called as a lens size. The longer is the lens focal length, the narrower is the angle of view. Now, what is field of view? Field of view is the area in width. The lens will allow us to see. In order to capture the image for a very small area like ATM lobby, one should choose 2.8 mm lens, which gives a very wider image and the near objects can be seen very clearly. Now, let's see how different CCTV lens covers the area. As shown in the image, you will see that the CCTV camera with a lens of 2.8 mm has a broader coverage width but covers very less distance. As CCTV camera lens goes on increasing, coverage width goes on decreasing but coverage distances increases. So this was all about CCTV lens. Hope you have liked our chapter. See you in our next lecture. Thanks. Hello friends, welcome to this chapter. In this chapter, we will learn about IP and IK rating of CCTV camera. First, we will learn about IP rating. IP rating system is the international standard that defines the level of protection against intrusion or ingress into enclosures by various things such as dust, solids and liquids. IP rating determines whether a camera or an object can be installed for outdoor application or indoor application. When looking for the IP rating, you should look for the letters IP followed by two numbers ranging from 00 to 68. The first number indicates the protection of the equipment against intrusion of solid foreign objects. The second numeral indicates the degree of protection against the ingress moisture. Let's see an example. Suppose our equipment has an IP rating of IP67. Then what does it mean? The first numeral is 6, and as per the details mentioned in this image, the 6 means that the object can withstand the ingress of dust for 2 to 8 hours and is a dust tight equipment. While the second numeral being 7, then it means that the object can be temporarily immersed in the water up to 1 minute and still it will be protected against the water or moisture. Let's see what is IK rating. It is a degree of protection provided by enclosures foreign equipment against external mechanical impacts. This table, as shown in the image, shows the different IK ratings and what they defines to and equivalence to. IP rating is from IK00 up to IK10. Then what does this IP rating means? Suppose we have an object, this is our object which has an IP rating of IK10. Now suppose an foreign object whose weight is 5 kg falls on this object, falls on our object from 400 mm with an energy of 20 joules, but still our object can withstand this mechanical impact and will be protected. Hello friends, welcome to this chapter. In this chapter, we will learn about NVR or Network Video Recorder. As name indicates, Network Video Recorder is a network-based computer system which records the video footage sent by IP CCTV cameras on an internal hard disk drive. Some of the NVRs include the same VMS software that can be purchased for your own computer, while others use dedicated software that only runs on their NVR. The NVR helps you to install and manage the IP cameras. The management software allows you to include a recording schedule for the cameras or use an alarm condition such as motion detection to cause the video to be recorded. NVR types are based on their operating system. Basically, there are two types of NVRs depending on their operating system. First is Linux-based NVR and second is Windows-based NVR. Linux is very well secure as it is easy to detect bugs and fix, whereas Windows has a huge user base, so it becomes a target for hackers to attack Windows system. And with Linux runs faster even with older hardware, whereas Windows are slower as compared to Linux. Software embedded NVR. This type of NVRs comes with pre-loaded video recording software, so there is no need to install an external video recording software on workstation. For this type of NVR, a monitor and a mouse is directly connected to the NVR for live view, playback and to do the configuration of CCTV system like setting up date and time of the NVR, video settings like resolution, FPS, bitrate etc. and storage settings can also be changed. While few NVRs comes with external video recording software. For these types of NVR, video recording software which is also called VMS installed on the workstation for live view to do the configuration of CCTV system like setting up date and time of the NVR or cameras, video settings like resolution, FPS, bitrate etc. and storage settings can also be changed. We will learn about external video recording software called IndigoVision Control Center in our upcoming chapter. Hope you have enjoyed this chapter. See you in our next lecture. Hello friends, welcome to this chapter. In this chapter, we will learn about CCTV storage and RAID type of storage system. In today's world, all visual and audio data is now in digital format. Each new day, surveillance requires new terabytes of storage space for the thousands of cameras around various cities, major towns and regional areas, including shopping centers, factories and prisons, to name a few. The need for data storage grows exponentially with every new megapixel sensor and with every new technology. The surveillance industry is one of the largest consumers of data storage media because of need for constant recording of information from cameras. As these recordings are very crucial and used for investigation purposes, data lost is not affordable. Now most of the CCTV manufacturers are coming up with different ways of storage redundancy. Short-term storage. Short-term storage is the recycling of the available storage space using the first in first out principle or called FIFO principle. In other words, if recorder have a drive capacity to store only 8 days, then in 8th day recording done at day 1 would have been erased from the hard disk, giving place to record the video footage of day 9. RAID type of storage systems. RAID stands for Redundant Array of Independent Disks. It is a way of storing the same data in different places on multiple hard disks or solid-state drives to protect data in case of a drive failure. These all are managed by a device called RAID controller. RAID controller may be a hardware or software based. Hardware-based RAID has physical hardware or controller which controls and manages the arrays, while software-based RAID uses the resources of the computer hardware systems such as the CPU and memory. There are different levels of RAID, or you can call it as RAID types. There are basically total 5 types of RAID levels. First, RAID 0, RAID 1, RAID 5, RAID 6 and RAID 10. Now let's see each of them and how they works. RAID 0 or stripping method. In RAID 0, data are split up into blocks that gets written across all the drives in the array. As shown here, data block 1 is written across disk 1 while data block 2 is written across disk 2, and in the same way other data blocks are written over two disks. RAID 0 is not fault tolerant. It means that if one drive fails, all the data in RAID 0 are lost. It should not be used in mission critical system where data loss is not affordable. Advantage of RAID 0 is that operation speed is faster as there are two disk drives for data operation. 1. Or mirroring method. Data are stored twice by writing them to both the data drive or set of drives and a mirror drive or set of drives. If a drive fails, the controller uses either the data drive or the mirror drive for data recovery and continuous operation. You need at least two drives for a RAID 1 array. RAID 1 is a very simple technology and offers excellent read speed and write speed that is comparable to that of a single drive. In case a drive fails, data don't have to be rebuilt, they just have to be copied to the replacement drive. The main disadvantage is that the effective storage capacity is only half of the total drive capacity because all data gets written twice. Software RAID 1 solutions do not always allow a hot swap of a failed drive. That means the failed drive can only be replaced after powering down the computer it is attached to. For servers that are used simultaneously by many people, this may not be acceptable. Such systems typically use hardware controllers that do support hot swapping. RAID 5. RAID 5 is the most common secure RAID level. It requires at least 3 drives but can work with up to 16. Data blocks are stripped across the drives and on one drive a parity checksum of all the block data is written. As shown here, we are using 4 drives, disk 0, disk 1, disk 2 and disk 3. 3 of them are used to store data blocks and the fourth one is used to store parity data. Hence, if we are using 4 disks, then only 3 disks can be used to store data. The parity data are not written to a fixed drive. They are spread across all drives as the drawing shows. Using the parity data, the computer can recalculate the data of one of the other data blocks. RAID 5 array can withstand a single drive failure without losing data or access to data. Although RAID 5 can be achieved in a software, a hardware controller is always recommended. In RAID 5, read data transactions are very fast while write data transactions are somewhat slower. RAID 6. RAID 6 stripping with double parity. It is same like RAID 5 but with a very little difference. RAID 6 is like RAID 5 but the parity data are written to two drives. That means it requires at least 4 drives and can withstand 2 drives dying simultaneously. The chances that the two drives break down at exactly the same moment are of are of course very small. However, if a drive in RAID 5 systems dies and replaced by a new drive, it takes hours or even more than a day to rebuild the swapped drive. If another drive dies during that same time, you still lose all your data. With RAID 6, the RAID array will even survive that second failure. RAID 10, or combination of RAID 0 and RAID 1. It is possible to combine the advantages of RAID 0 and RAID 1 in one single system, as shown here. Using RAID 0, data blocks are first strapped over each set of drives, and the same data blocks are mirrored over each set of drives using RAID 1. If something goes wrong with one of the disks in RAID 10 configuration, the rebuild time is very fast, since all that is needed is copying all the data from the surviving mirror to a new drive. This can take as little as 30 minutes for drives of 1 terabytes. Half of the storage capacity goes to mirroring. So, compared to larger RAID 5 or RAID 6 array, this is an expensive way to have redundancy. Hope you have liked this chapter. See you in our next lecture. Hello friends, welcome to this chapter. In this chapter, we will learn about how to calculate storage and bandwidth requirement. In order to calculate the storage and the bandwidth, here we are using a manufacturer storage calculator, which is from ACT. Here, the step first is to select different ways to manage storage plan. There are two different ways. First way is to select how much storage space is needed. It means we have to calculate the storage space, and we can get the bandwidth and the storage requirement here. And the second option is to get how many days can video be stored. Most of the time the client will ask for the second option, how many days can video be recorded. So we'll select the second option, and if you'll see on this below, storage space which is in TB, and it's mentioned here is default 10 TB. Now second step is to add the cameras with different parameters or settings. First you will see model that you can select. It's right now it's generic. We'll go with another camera model number. Suppose A21, we'll select A21 model number camera, and the amount of camera, let's say we have 10 cameras for this project. And stream mode, we have dual stream. First stream is for recording, second stream is for live view. And the stream 1 resolution for recording, if the project allows to keep for 720p, so we'll go with the 720p resolution. And the camera frame rate, which is called FPS, frame per second, that we will keep 15 FPS. Compression will use H.264. If your cameras allows H.265 or network video recorder allows H.265, then we can go ahead with second option H.265. But here for this instance we will keep it H.264. Video quality we will keep it for medium. Recording hours per day is 24/7. We'll keep as it is. Now stream 2, the stream 2 which we are using for live view, we'll select VGA, quality of resolution, and the camera frame rate we'll keep it for 30 FPS. Compression same, we'll keep as it is H.264. Video quality we will keep it for good. And recording hours per day, we don't want recording here for live view, so we'll keep it 0. Now this is the calculation done for the one set of camera, one model set of camera, which is around 10 number of cameras here. Suppose we have another set of cameras, and the model number for those cameras is A22. We'll select this one, and the count of this camera, suppose it's 5, And the same settings we will do it here. We'll replicate same settings which we have done earlier. Same settings we'll do it. We'll keep it this for 15 fps, video quality medium. Okay, then stream 2 we'll keep it for VGA, fps 30, video quality good, and we don't need recording here. Okay, now in the below you will get the calculation result which shows total amount of cameras. Here it's 15 and the total bandwidth required is 22.5 Mbps, and how many days we'll get the recording is 125 days. Suppose your requirement is to get the recordings only for 30 days. In that case, we can change the storage space from here. Suppose we want only to keep the recording for 30 days only. So what we'll do, we'll change it to, let's say, 3 TB, and let's see, it's coming up for 38 days recording. Now it's changed. So for this project we will need only 3 TB of hard disk. In order to get 38 days of recording, we are keeping 8 days as a buffer. So with the same settings, if we apply on the at the site, we'll get this 38 days of recording. Hope you have liked this chapter. Thanks. Hello friends, welcome to this chapter. Ethernet and PoE both restricts cable distance to 100 meters between network ports. However, PoE power devices such as IP camera points are frequently located at far greater distance from the nearest network switch or power outlet. In this chapter, we will learn about what to do if a network cable length is more than 100 meters for a IP CCTV camera. As data and PoE transmission over a network cable has a limitation of 100 meters, this should be a challenging situation for a CCTV designer. But no need of worry, there are few options available in the market which can help a designer to design the CCTV network structure which will allow data transmission for more than 100 meters. Let's see each of the options. There are three options available to transmit data for more than 100 meters of network cable length. First option is using PoE extender. Second option is using fiber optic cable, and the third option is wireless access point. Now let's see each of the options in detail. Let's see our second option, fiber optic cable. This option is very helpful and can transmit the data over a very great distance, which may be up to few kilometers, and also this cable is very immune to the noise and interference from electromagnetic signals and radio frequency signals. As shown here, a fiber optic cable has been laid from a network switch to the net camera using a fiber media converter. As shown here, a fiber optic cable has been laid from a network switch to the camera using as shown here, a fiber optic cable has been laid from a network switch to the camera using a fiber media converter at the camera end will convert the fiber optic cabling to twisted pair cabling. But we must be careful while using this option and must ensure to have the power near to the camera as power can't be transmitted. Let's see our third option, using wireless access points. Using this option, data can be transmitted wirelessly without using any type of cables between the network switch and IP camera. And the distance between these devices may go up to kilometers. But at the same time, we must ensure that there is clear line of sight between wireless access point transmitter and receiver, and there should be no interference between them. As shown here, videos of the cameras installed at Factory 1 and 2 are transmitted to the headquarter office wirelessly using wireless access point at each locations. We must also take care of the bandwidth requirement of the CCTV camera, and it should be within the limit of the wireless access points. Hello friends, welcome to this chapter. In this chapter, we will learn how to connect a CCTV camera to your laptop. For this setup, we have used an IndigoVision IP Dome camera and whose IP address is 192.168.2.100. This IP camera is connected to a PoE switch, and our laptop whose IP address is 192.168.2.2 is being connected to the same PoE switch. Now let's do this configuration for this setup. In order to connect our laptop with an IP CCTV camera, both laptop and IP CCTV camera must be in the same network range. As we know the IP details of our camera, we will assign the same IP address range to our laptop. Let's assign an IP address to our laptop. In order to assign IP address to a laptop, we will go to the network and sharing center. As you can see, my laptop is connected with two networks. First is the wireless network of my home Wi-Fi router, and second is the local area connection on which IP camera is wired to my laptop via PoE switch. Let's open the properties of local area connection on which an IP camera is wired to. We'll select here Internet Protocol version 4 and we'll open its properties. As you can see, that my laptop is without an IP address. We will assign a static IP address which will be in the same range of our IP camera. IP address of our camera is 192.168.2.100, but for my laptop we will use an IP address 192.168.2.2 and the subnet mask will be 255.255.255.0 and the default gateway will be 192.168.2.1. Let's save the settings here. Now, how we can check that our laptop has started communicating with an IP camera? For this, we have a very useful Windows tool which is called command prompt. Command prompt can be opened by pressing Windows and R key, which will open a run window. In the open text box, we have to enter text CMD and press enter. You will see a black window will appear. This is our command prompt tool. In order to check whether our laptop is communicating with IP camera or not, we will type a command here which is ping, P-I-N-G-S, P-I-N-G space 192.168.2.100, which is an IP address of our camera, and then press enter. As you can see that we are getting replies from the camera. It means that my laptop is able to communicate with an IP camera. Now let's open our camera on browser. I will always recommend to use Internet Explorer to open CCTV camera web page. Now let's enter IP address of our CCTV camera, which is 192.168.2.100. Now, as you can see, we have landed on camera login web page, and the username here is admin, and we will enter the password associated with this username. After entering username and password, we will land on the live page of the camera. On the live view, you will find two stream tabs, which is here, first is the main substream tab and second is substream tab. Let's select main substream on mainstream tab. Now let's select mainstream on mainstream tab. You will see some information on the live view page of the camera. On the left hand side, you will see the bitrate of your camera, which is changing continuously, and on the right hand side you will see resolution of our camera, which is set here to 1280 into 720p. Similarly, you will see different text available on this live view of the camera. Like on the left hand side, you will have a text overlay which is named here as headquarter. On the right hand top side, you will see a present date and time stamp. And on the bottom right hand side, you will see channel title, which is named here as main entrance. Now, as you can see, we have total of 5 different tabs available here. First is the live tab, second playback, setup, alarm and logout. Other tab important features we will see in our upcoming lecture. Hello friends, welcome to this chapter. In this chapter, we will learn how to scan network using Advanced IP Scanner. Advanced IP Scanner is a free network scanner tool which we can use to scan our network and list out all the network devices available in the network. This result can be exported in the CSV format if required and can be later used for other purposes. Let's first go to the Advanced IP Scanner tool website. For that, we will type on the Google, download Advanced IP Scanner. Now we'll go to the website. Click on free download, and download has started. We'll wait for a few seconds. Let's install the advanced IP scanner tool. Select English as a language. This we have to install on our laptop. We'll select next, accept the agreement. Now this is our advanced IP scanner tool and this is the GUI of the same. And now we will connect laptop with our IP camera and we will see how to scan the IP addresses in the network. Under File menu, you will find different options like load favorites, scan from file, save as, print preview, print and exit. Under View menu, you will find different options like expand all, collapse all, show alive, show dead, show unknown and like many others. Under settings, you can select different settings available here. You have to go and you can select the scan resources from HTTP, HTTPS, FTP, etc. And this is scan button here. So now this is the IP address field which we have to enter. We know that our IP address of our camera and the laptop range is 192.168.2.1 to 192.168.2.254. Now this is our IP address range. So we will scan the IP addresses within this IP addresses range. On the below you will see the status of our progress. Still ongoing, still searching for the network devices, and here you will see its scan progress result is 99% is done. Oh, now it's 100% completed and it shows 2 alive, which means we have 2 network devices which are alive in our network, 0 dead and 252 unknown, and there are 252 unknown IP addresses in our network range. As you can see, we have status, name, IP addresses, manufacturer, MAC addresses, comment. Status, this is the live status of our network devices. First one is ATC-Nilesh. It's showing the IP address of my laptop. It's showing the name of my laptop with IP address 192.168.2.2 and manufacturer of this laptop is HP. MAC IP address as shown here. In the second, you will see the IP address of the name of our IP camera, which is 192.168.2.100, and the IP address is same 192.168.2.100 with manufacturer has this Indivision cameras, shows Indigo Activision Systems Limited with MAC address. Hello friends, welcome to this chapter. In this chapter, we will learn about how you can convert a wired camera into a wireless camera. Let's assume that your customer has two factories, Factory 1 and Factory 2 at two different locations. And customer wants to install CCTV cameras at these two factories and wants to view these two factories CCTV camera at his headquarter office. But the problem is that there is no existing network infrastructure available amongst these factories and headquarter office. And the other problem is that optical fiber can't be laid amongst these factories and headquarter office due to some reason. Now, how we can solve this issue? This issue can be solved by using the wireless access points at all locations so that the CCTV data can be transferred from these factories to the headquarter office. But before using the wireless solution, we must ensure that there is clear line of sight between this location and there should be no interference to the wireless signal. Now, what we can do is that we will install a wireless access point transmitter at the roof of the factory 1 and factory 2 or at a location where we can get a clear line of sight to our headquarter office wireless access point receiver. Now we will connect this wireless access point transmitter to a PoE switch where all the CCTV cameras are connected or networked. Now video from this CCTV camera will be transferred to this wireless access point transmitter via network switch, and then this wireless access point transmitter converts this signal into RF signal, which is then received by wireless access point receiver installed at the headquarter office as shown in the image. Now wireless access point receiver sends this received wireless signal to a network switch where our NVR or CCTV workstation is connected. Hence, by using this technology, our customer can view the live video or can play back the recorded video of different remote location factories. But we must keep in our mind that the selected wireless access point should be capable of handling the bandwidth required by the CCTV system. Hello friends, welcome to this chapter. In this chapter, we will learn about general things which we need to consider while designing a CCTV system. Purpose of CCTV system. As a CCTV designer, we must always ask the customer about the requirement and what is their purpose of installing CCTV system. Is it to prevent vandalism, theft, employee theft or litigation? This information will help us to select the cameras and their placement also. And for specific requirements, it also helps us to determine about the specific frame rate and resolution required to achieve. For example, a camera installed in a staircase will have a different frame rate and resolution as compared to a camera installed at a cash counter of a bank or shop, which requires higher frame rate and higher resolution. And similarly, if a customer wants to know the vehicle license plate number, then a special type of NPR camera is required to fulfill this requirement. So, a CCTV system designer must ensure that all the customer requirements are noted down and provides a solution according to that. Important areas for surveillance. This is the most start point and every CCTV designer should have this information from the customer. To monitor and record the footage of this critical or highly sensitive area, additional cameras should be installed so that there should be no blind spot. Environmental condition also needs to be taken care of. If this area is an outdoor area with low light during night time, then camera with night vision capability should be installed. Existing CCTV system availability. If a customer has already a CCTV system available, we should be clear about following points. Is the existing CCTV system is an analog or IP CCTV system? This will help a CCTV system designer to select new CCTV system type, whether it should be an analog or IP based system. Second, do customer want to remove the whole existing CCTV system or wants to add few cameras to the existing CCTV system? Next point is do customer prefers to use the existing cabling infrastructure with the new CCTV cameras or NVRs? Many times customer wants to use their existing cabling infrastructure, but as a CCTV system designer, we must ensure that the existing cabling infrastructure meets our new CCTV system requirements and the existing cabling is under good condition. Next point, if customer wants to add few cameras to the existing CCTV system, we must ask the customer about the recording duration required, as most of the cases additional hard disk drives will be required. And the last point is, and if the customer wants to add more IP cameras to the existing IP based system, we must ensure that the new IP cameras should be compatible with the existing IP CCTV system. Nowadays, all the IP camera supports on-with protocol, but still we must ensure that the new IP camera on-with protocol supports the existing CCTV system and we are able to get all the required features as mentioned by the customer. These are the few points, and you can also add your points also while designing a CCTV system. Number of rooms or areas required for surveillance. This will help us to get the total number of cameras, switches and storage calculations. This plays a very critical role while designing a CCTV system. Every CCTV system designer should have this information. Location of CCTV recording server or control room. As a CCTV system designer, one must have this information and let customer also aware that NVR or recording storage server must always kept in a secure place so that an intruder should not easily tamper with the CCTV system. In case of large organization or business areas, there may be a requirement of the CCTV control room where a dedicated CCTV operator monitors the entire premises via CCTV cameras and takes preventive actions upon finding any security related issues. We must ensure that the CCTV control room is properly designed, like control room should be enough big to accommodate CCTV hardware such as monitors, workstations, servers or recorders, etc. Control room should be well air conditioned as there are CCTV electronic equipments which will operate 24/7 hours. Distance between CCTV monitors on the wall and the operator's desk should be at least 8 feet and the viewing angle should be 30 degrees. Control room CCTV operator should have all the locations blueprint layout and if possible CCTV camera should be programmed on this map layout. This will help an operator to navigate the CCTV cameras. Use of advanced designing tool. There are many CCTV system design tools available online in the market which helps a CCTV system designer to design and choose the camera as per the site requirement. From this tool you can calculate field of view, lens focal length, CCTV storage and bandwidth calculations, resolutions, coverage area, etc. These reports can be generated in PDF, Word or Excel format to create a high quality project visualization.